Hi, can you hear me on the back row? One of you? Yeah, okay, great. So my name is Deepak Sahoo. I'm from the Future Interaction Technology Lab in Swansea University. So the name of the lab and today's topic is like just coincidental. There is no relation to that. So it's a view from just outside Swansea, call it Mumbles. And we have very nice landscape there, and that's from where we get our inspiration, things popping out from the water. So this is the view of one of our campuses, Singleton campus. And we don't have tall buildings, so we don't really get to see this view, but I really like this photograph. And so between the beach and the campus, there's a road. So we thought like we'll move to the new campus where the campus is just on the beach. And this is our new building. We call it Computational Foundry. So Wales is well known for forging different things, and we thought we'll forge, instead of copper, some computational things. And this is our foundry, which is scheduled to open in September. And I'd like to get in touch with more people and invite and show our new building and see build new collaborations. So obviously we are growing and we're hiring, so if you're looking for positions, maybe look up Swansea. It's not a bad place. Okay, a bit about me. So I'm a lecturer in human-computer interaction, been like a year, so very new faculty. Before that, I worked in HCI with Sriram Subramanian, and I was in Sussex and Bristol. Before that, here I'm building interactive devices for the last few years. But before that, I was in IBM-Research Research Laboratory, and there I was building scientific instruments. So I got bored of science. There was no human there, interaction, so I thought, come to HCI. And before that, I was again doing nanotechnology, material science kind of things, both at IBM and in America when during my PhD. So you'll see a bit of mix of HCI and materials in my talk. So that's where my background comes from. Before that in India. Okay, so coming to today's talk, so future interaction technologies, and that's beyond the screen. So hold on a second, and what's your idea about future interaction technology? Can you just take 5 seconds, think about it? Just your thoughts. Okay.
Reports the best thing ever.
Oh, I'm sorry. I took that slide out. It's old. It's like flat screen. So I went to the avatar. It's not a flat screen. It's a 3D display. So it's not a video. It's a 3D display where they can pan and look at all the architecture on the planet. But there is one thing missing there. It's like, it's nice 3D display, but something missing when they're browsing through the data. They can't really feel it, so the haptic part is missing, so it doesn't feel really real. And maybe that's why when our protagonist went through the real world and felt and saw these things, touched them, smelled, he fell in love and then he switched sides. Maybe. Don't know, but and then this is a thing people imagine now. We have 3D floating screens and everywhere, naturally appearing on demand and disappearing. But again, there is something that doesn't feel real because we don't have haptics there. So what is interesting is what comes up here, like Iron Man. So there is this digital information. We have the 3D display, and then he has this thing in the real world, like a tangible, I think it's a power source, and he puts it right there. And there is a seamless transition from a real object to the digital world. So what we imagine the future will be this, having a seamless transition from the real world to the digital world. So back and forth. You put somewhere in and bring it back. It's kind of fiction, but can we go there? Or can we create that interaction in some other way? So I think this is my inspiration. Like what future needs is actually some kind of natural interaction. It's not like, nowadays if you wear headsets, HoloLens or something, then you can create this hollow table of avatar. But really the haptic part is missing and it doesn't feel natural because we're blinded. We're not there in the real world. So what we need is actually some kind of natural interaction. And we need some kind of tangibility to go along with it. So, so my interest on this talk, we'll see how we can incorporate some haptic interfaces to bring, to really have this kind of interaction scenarios. Okay, so what we have is basically a boring smartphone. So I'll start with a mobile phone. So we have a phone which is, if you look at your phone, it hasn't changed its shape or the feel for last few years. So that's why we have, like the article in Sun saying it's a shy phone. It's like, it looks the same, feels the same. We touch it, it's just a glass surface. It hasn't changed a lot. So what we want to do is bring that kind of physicality into the digital instruments in some way, and this is where I operate, bringing the physical sciences and the human interaction. I'll show some examples. So first one is tangible drops. So may I ask you to, if you have your phone in your hand, like just hold in your hand and touch it. Even if you have the screen on, touch it, what you feel? It's just dead surface, just glass. Even if you see something, a visual, what you see is just visual thing, but it feels just glass. So that's why you saw in the keynote that everything is driven by a visually driven. There is no haptics. And without haptics, we have sound, but without haptics, it doesn't really feel the same. If you see a picture, if a map, no, it doesn't really connect with the real world. So what if, if you give haptic sensation, the entire device vibrates, So you don't really get at the fingertip as we touch something. So what we want to have is something that is different from vibration. What if we have a robotic thing that is somewhere around this case and comes to your hand when you want it, gives you the haptic information, position, direction, things like that. And when you don't need it, it goes away, and you have the phone. And you have location, local haptic feedback. Can we do something like that? So we looked at it, like, is it possible? So we worked on a material called liquid metal, and to see if we can really move a liquid metal or some kind of material on the surface, which can come and interact with the finger and give us some digital information in a haptic way. So I did that. We did that in Swansea, and my co-author team is here, and like we both contributed equally to it. So what we see is, not only we can move the material, but we can also vibrate it. So we can control the vibration and locomotion, so that we can give exploit different modalities to give different kind of sensations. So not only it can vibrate and move, and at the same place, so that it can change different directions. So imagine if we have something like that on our phone, and when we touch it, it gives all different kinds of haptic sensation. It will be really useful. So for example, if the phone comes, you can imagine as like a micro robot. So we are touching the phone, it comes, and then it touches in different, gives touches in different directions, angular directions, and maybe it could be used to give us eyes for interaction, for example, navigation through maps or navigation through menus, things like that. So we did a user study also on it, and we saw that the users can feel the position and the direction of the haptic sensation, and also we tried different other techniques. Apart from haptics, it can also show a visual information, because the micro robot on a flat surface, it can go and show different visual information. So using material science, one can find different ways to give these haptic surfaces, maybe on the mobile devices, and we can create different kind of widgets on our mobile phones, maybe, and on top of it, we can also help maybe people who require special attention, or even for us, eye-spray interaction. So by looking at it, we can imagine that, okay, it could be useful, but it's not really there. I don't really see it on our phone unless the technology of display goes beyond what it is now. It's now flexible, but if we have a very flexible thin film display and we put this kind of materials underneath the display, then it will be possible to move the material around and give this kind of sensation. So it kind of depends on the display technology in a way. So we looked at, is it possible to really have a technology that can work on today's mobile phone? So I'm sure everyone remembers when in a dry environment, we go to the door, we touch the knob, what we feel. In winter, we go touch the knob, we feel a shock. It's quite like we don't really use nakeds. It's not really useful, but can we really control the shock? Put it in the mobile phone, and then it would be really localized. And is it possible to control it and give different kind of sensation? So, and is it possible to put it on the phone? So we looked at that. So this is the initial prototype where there is arc, and the temperature is the voltage is 30 kilovolts, and people are touching it. It's not my finger, it's my co-worker's finger. I built the system, asked him, oh, get tried. So he was a brave guy. So he did the first attempt, and after that I was fine to touch, but I made it touch first one. Okay, so this is arc, and we wanted to make it touchable and think and investigate whether we can create different kind of textures or can we implement on mobile phone. So how to make it touchable? So nowadays there is research where it's not only on mobile phone, we not only touch input can be detected, even hover input can be detected. And we have different sensors to interact touchless on mobile surfaces or on desktop surfaces. So it's possible to detect the finger position and then control the shock so that it's touchable. So that's what we did. And we made it touchable, and it can go up to a centimeter. Yeah, we can feel like it goes, so we see the arc until 7, but we can feel until 10, and arc is just like not visible, but we can feel up to a centimeter. So now we can imagine that on our phone, the interaction is not just swiping, touching, the tapping, double tapping, things like that. But once we can hover on top of it, we can also do tap, swipe kind of gestures, but other gestures. And at the same time, we can get feedback. If it can be put on the phone, then we can get all kind of feedback just in the hovering mode. So this is a kind of interaction that could go beyond the way we use our smartphones. So we looked at how different ways it can be implemented. So you can have pins on desktop surfaces, and then like wire mesh kind of thing on wall, or maybe, or on different surfaces. And then we checked, is it possible to do on phone? For example, this is the transparent electrode, and if we put a transparent electrode on top of a phone, we can feel it. So we can feel this thing on a phone, and hopefully, okay, I don't know how many people want to put 30 kilovolts near their phone, but it's possible, and see, it can be doable. So this is the kind of technologies one can imagine to bring to our mobile devices to create new kind of interaction scenarios. From the phone, we see that again the phone is flat, not to touch. Visually, it's also flat. We touch it, it's a hard, rigid surface. Nowadays, there are technologies where we have flexible displays. So you can put a flexible display on a phone, and the phone, probably the PCB could be made flexible, and then you can bend and twist and do different things with the phone. But the technology is not there where we can really, interact with the phone naturally as if we do with our clothes, for example. Do this, that, all kind of things. Like when you look at something flexible, we want to interact in more ways than just bending, twisting, like pinching, pulling, and ripping it apart maybe. So we looked at how will it possible to bring in all those kind of interaction modes to displays with, of course, haptic feedback. So this is what we developed where, the display is obviously not a flexible one, it's a fabric display. And there is no projection from the top, there is a projection from below, so there is no occlusion. So you look at it, and then we used transparent electrodes to vibrate the surface, and we can do it locally depending upon where the electrodes are. So now we can imagine display surfaces where we can really do anything, punch it, pull it, do anything with the surface, and interact in different ways with the display and with the haptics incorporated into it. So here we're simulating an earthquake. So someone touches this thing, it's like a epicenter or something, and then the earth vibration. We use that for teaching. You could create animations, for example. Is it moving? Yeah, it is. Yeah. So now instead of digital animation, you can see the phone, the tabletop surface really doing the animation, and it could be useful for a collaborative environment, and it's really 3D because you don't really need to wear 3D glasses or things like that, and it's something happening in 3D, and you can touch it, you can feel it, and everyone can share the environment. So it's really cool. And for example, if you can show things like pinching, pulling, those kind of interaction, gesture inputs, and at the same time, so you can get localized vibrations for notifications and interactions. For example, here, if someone is going from one point to another, you can guide them. You could see them visually, and also in a haptic way. Also, you can touch and go. You can try to do it in an eyes-free manner or in a visual manner. So, okay. So this is one example. Now the thing is, we have a mobile phone, then you have a tabletop surface. To interact, to get more information, digital information, is it the only way we can get it? Something in our hand or something in front of us. We have lots of space around us. Can you use it? That's what is there in the movies. That's what designers think. Oh, something that appears in front of us when we need it and goes away. So that's where the future lies. Something on demand in front of us in the space, maybe personalized, or maybe we share it with others and needs to be controlled. So there is also a lot of work to be done in that space. So we looked at it in a project called Dynamic, where okay, maybe I'll stop it. So what we put behind, this is a two-way mirror. Behind the two-way mirror is a stereoscopic display. So you see the stereoscopic display, which is this cube, for example, is in the virtual world. And to put yourself in the virtual world is the two-way mirror where you see your reflection. Instead of a camera capturing you, reanimating, putting you in the virtual world, you see yourself in the reflection in the virtual world. And then how do you interact in a more natural way? So if you post yourself in the camera captures and reanimates. It doesn't really, it can be really done quickly because of all the processing, lag, everything. But this is a nice way where you see yourself in the mirror and you can manipulate objects, and it's quite doable. So that's what is happening is, how do we control objects in the virtual world using this? So what we have is a shape-changing mirror. So when we want to grab a bigger object, in reflection, the hand becomes big. So if you want to grab a bigger object, obviously my real hand is not changing size, but in reflection it changes, it becomes bigger, so you can grab bigger objects, like a stretchable thing. And want a small object, you can, in the reflection, it makes a smaller one. And if you want to take something from the real world to the virtual world, we can again do in the reflection. So this is another way of interacting, bringing in that seamless merge between the physical and the virtual world. This is one way of doing it. But then it's kind of really personalized. We don't really, it's not very group friendly. A lot of people interacting with it's not there. What if instead of a mirror and a fixed thing and a little dark environment, there is something that comes up, in the free air, and it goes away when you need it? Is it doable? That will be really nice. So, we thought we worked on this one, where it's a mid-air display, where there is an array of polystyrene bits which are levitated using acoustic wave. So though, like for video, we have like black screen behind it, by using acoustic levitation, we can really levitate objects, and it's just there, you can move. So if you put it in between us, for example, I can see you, you can see me, and then there is this object, there is this screen, but it's just white screen. Can we do some kind of information, like show some information on top of it? So, of course, the screen can be moved so that we can do a different kind of animation. But can we do something like this, where we can color the bits, one side white, one side some other color, and then rotate, flip it to create animations. So this is a winking thing, and we can do it. So it's like an e-ink display. So we don't need any lighting, no backlighting, nothing. It's just the color of the bit, one side white, one side colored, and it's flipping. So by flipping, it's like a levitated e-ink display. So we can use it like when we want it on demand. It's not what we saw in the movies, like it's coming just like that, but something that can come up, do things, show us information, and goes back, and can we touch it? Now there are technologies using ultrasound where we can feel the air pressure in a hand, so we can see it, and possibly we can touch it. So, and also using this, we can create different kind of animations where it's not the entire display, but something that is in midair, where this one is going and it's flipping on top, and then goes. So this is, I think, this is where the future lies, where we want to have something that is more natural. So we don't really instrument the user wearing headsets, wearing gloves, but something that is people are not instrumented. They are interacting with more naturally, and with new modes where it's not just swiping, tapping, limiting, but with a lot of natural gestures. So we want to increase the gamut of gestures, for example, and we need to bring in this tangibility into it. It's not just creating the digital side of it, so having the same old smartphone or display, but bringing in innovations, some kind of material innovations to displays, and creating that scenario where people can interact with the digital world in a more tangible way. And definitely we need more haptic interfaces. I'd like to thank the PIs. I worked as a lecturer for 1 year now, but without the help of my previous PIs, like current PI, it won't be possible. And of course, my colleagues, team who is here, all this work won't be possible. So, what we want to have, so we worked a lot on mobile phone, and what we want to have is very user-friendly. What we don't want is this. Wow. So with that, I would like to thank you. Yes, because now, so what the liquid is caustic soda that we use as a drain cleaner. So it's not really touchable. So we need some. So we need some protective layer on top to touch it. So if the display is really thin and this material underneath can vibrate the display locally, deform the display locally, could be possible. Yeah, we need that thin display to feel that bump, yes.
It's pretty worth saying that we did experiments with cling film, and it works actually. And you can feel the cling film, and the caustic soda doesn't get to your fingers. However, big problem. Surface tension and things like cling film tends to mean that the liquid wants to escape down the sides of the device. with the current implementation.
So a few more technical problems.
Yes.
I was just curious. Okay. Any more questions? Yeah.
Out of everything that you've been investigating, what do you think will have more traction in the near future? Out of all these different tactile experiences, which one do you think? Or you kind of forecast and see, yeah, that might go ahead?
Yeah, so definitely now what we use is vibrating the entire device in most of the phones. But what is getting traction is like iPhone is like always coming with new technologies. This haptic touch where we don't feel the entire device vibrating, but something localized. So I think in the near future, what will come is there are different research papers where they are trying to create this haptic sensation locally. So that is what will get traction in the near future. So we can feel textures while touching the phone localized. So, but then will come if we can do in-air gestures and again feel in-air haptic feedback, things like that. But it's definitely coming where we feel textures locally.